In this video, we're going to learn how to evaluate the integral of e to the x times cosine of x using the method of integration by parts. Let's begin by writing down our integral. The integration by parts formula is integral u dv equals uv minus integral v do. For our integral, let's choose u equals cosine of x and dv equals e to the x dx. Thus, do becomes negative sine of x dx, and v becomes e to the x. Let's compute uv, which is e to the x times cosine of x, and substitute into the integration by parts formula. Applying the integration by parts formula, we have the original integral equals uv minus integral v do. This becomes e to the x cosine of x minus integral e to the x times negative sine of x dx. Let's simplify this expression. This simplifies to e to the x cosine of x plus integral e to the x sine of x dx. Now we have a new integral to evaluate. Let's again use integration by parts on the new integral, with u equals sine of x and dv equals e to the x dx. Then do becomes cosine of x dx, and v becomes e to the x. We'll apply the integration by parts formula again. After applying integration by parts once again, we have the original integral equals e to the x cosine of x plus e to the x sine of x minus integral e to the x cosine of x dx. Observe that this new integral is the same as the original integral. Since the original integral equals itself, we can isolate the original integral by adding it to both sides, giving 2 times the original integral equals e to the x cosine of x plus e to the x sine of x. Dividing both sides by 2, we get the solution to the integral. Including the constant of integration, the solution is e to the x times cosine of x plus e to the x times sine of x over 2 plus c.